All right, here is some additional work with Cairo and drawing. This is a hack. What I'm done here, a hack alert, is that most of you, if you've used Linux, you've seen Pulse Audio Volume Meter. The real name of this code is Pavumeter, P-A-V-U-M-E-T-E-R. It's open source. It appears to have last been modified around 2006 or 2007. Nobody's changed it since. It's using functions which are becoming deprecated, but it still works, and it's still, of course, the only one you've got, unless you're using Jack. Jack does have some nice-looking audio meters. I think no one's actually gotten into it because it's almost impossible to read. It's in C++, and it involves getting down into the Pulse Audio API, for which there is almost no documentation. It's very obscure. If there is documentation, I can't find it. It's a callback routine. It runs through glib. It's very complicated. This code works. The question was how to alter this code so it would work with something more like a VU meter, which is what I've done. So first of all, I'll show some examples. You can see the audio meter. It's picking up my voice. Hopefully that's my voice. Because there are music things here, which I have got turned down so they won't play and I won't get in trouble with YouTube, but you'll see them running. All right, first of all, what I've got here is, let's go over here, the VU meter. It's VU meter-bin, my version of it. And we're going to look at the results. Let's see, let's just go with the standard one with no parameters. With no parameters, it's going to come up looking like this. Looks like a VU meter. You'll notice there was a warning message up here. Ignore it. It has to do with C++ and the dynamic linking to the callback routines. C++ is not happy with the way Glade is doing it, and there's not much I can do about it except I manually insert the callback, but you still get a warning. It doesn't affect anything. Okay, this is what it looks like when it comes up. Now, the background here is just something. It's just an image. The image is in the file. It's called meter.png. You can change it. And it's got no particular significance. You could put a picture of bunny rabbits there if you wanted to. Or you can disable it by saying no image. All right, here is a file which I'm going to play. And hopefully here I'll check OBS. The desktop audio is turned off. And so when it starts playing, you'll see this meter start to respond. It's not actually going to play over in this meter here, but you can see now the two needles. The red needle is the right, the green needle is the left, and it's chugging along doing playback stuff as it's playing Baker Street by Jerry Rafferty, which I hope is not coming through the audio or I'll get in trouble. Okay, that's one way of looking at it. I'll kill that. I'll kill this. We can then go to dash, if I remember all of my things, no image. If you get it wrong, it'll give you all the options. Okay, now it comes up like this. Black means that they're equal. So if it's a monaural, it'll be black, and at the moment there's nothing playing. Now there's no image. The meters are, the needles are actually larger as a result. And you'll see it, there it goes. And now it's just needles with no background image. You could go in there and play with it. You could modify the image, do anything you want to it. But all right, so that's another way of running it. And I'll kill that. All right, no image, and another one is arc. Okay, so now you'll see there's the two needles are here, but they're now forming an arc when they start running. All right. Now some people like this, some people don't. It's up to you. The red is the the red is the right and the green is the left, and you'll see the arc popping across. All right, let's say we don't. I'll leave the Rafferty thing running. Filled arc. Filled arc. Now you see it looks like that. Okay, which is kind of nice, I guess. All right, were there any others here that I skipped? Let me just type in here with a mistake on it. It'll show me all the things. Okay, dash playback. It's picking up the playback. In other words, it's picking up the sound coming through the player there. If I wanted to pick up the microphone, I'd put dash record. Needles is the default. It shows you needles. If you say --arc, you'll get unfilled arcs. Filled arc, you'll get filled in arcs. No image or image. Image is the default. The stars indicate which are the default. So those are the various options. They're all just variations on the same thing, obviously. The file back here, there's the code. It's CC. The meter.png, that's it. If you make something the same size, it'll work. You can adjust the size and play with it, of course. But if you've got something you'd rather have, that's just some public domain image I found on Google, and I added my own little logo to it. Okay, what else have we got? Because a million little things here. First of all, the Glade file for it. I'm going to get rid of this. We don't need that. I mean, this works fine if you like the, somewhat large. It's, if you like bar graphs, it's fine. But anyway. All right, what have we got? This is similar to what's been done before. As we got fixed, we've got the image. There's the image. It's got a name. There's nothing set up to be, the image isn't sensitive to anything. There's no clicks or anything on it. We've got the drawing window. The drawing window is right in here, okay? And the whole container shrinks down to the size of the actual content here. In the drawing window, under signals, we've got, where are my signals here? Draw, on draw one, draw. That's the one that doesn't work. That's the one that the draw signal is supposed to cause it to draw, and that's the one that's not working with the builder. Don't know why. So that's the only one I got in there, I guess. Yeah, that's the only signal. It's the only one that doesn't work too. The image, of course, you could change, and you could resize this thing, and if you resize this, you'll have to go in and resize the size of the needles and so forth. But anyway, so I get rid of that. Now let's look at the code. As I said, this is hacked code. It's not going to be very pretty. But I wasn't going to rewrite the interface to Pulse Audio, even if I had the documentation, so I just used what was out there. I had to remove a lot of the original author's code because it was, of course, creating that bar graph. And so a lot of it's been hacked out. And so this is, I've tried to identify what sections belong to the original author and what sections are mine. As I said, they're both GPL. So there's, I gotta remember to type VI and not VU, or just plain V will bring up the VU meter. Okay, there is at the top here, we're actually going to see the code that was originally there. I'm not going to take too much time in it, other than to notice at the very top there is 4 global variables, L, R, LX, and RX. These would be left and right channels. And then there's a lot of code. That's apparently the person that wrote it. His name is Lenhart, or her name, I don't know. Don't know the name. And you see the last modification date there is listed as 2007. Now, the original code here had the makefile from hell. It was I wasn't going to get into that either, so I modified that. Let me before I go any further, the compile script. That's what the compile script looks like, and that gets around the makefile. If you like makefiles, you can build your own. I don't particularly like them, especially with a program that's only a couple hundred lines long. Makefiles doesn't seem to have a lot of. But if you wanted to tailor it so that it would work with different systems, but of course it's basically going to be running on a GNOME system with a with GTK. So anyway, in this thing here, it's G++ because it is a C++ program underneath. My code is C, but that'll work with C++, of course. It's got a bunch of PKG configs here for GTK MM-3.0. Many of these were 2.0 in the original, so I've upgraded them. These insert the flags and library information necessary for that particular package. There's GDK MM. There's a glib MM 2.4, that's the most recent, a GIO MM 2.4. So, notice the back quotes there. What that does is it runs the program pkg-config, passes these parameters to it, and it responds by giving you, or belching out, a huge number of parameters that are designed to be used with the C++ compiler. So, yes, you're ready to go. Let's see. glib 2.0. I wonder if that's even necessary now after didn't I put a glib in there someplace? I don't know, but anyway, it's in here. There's others. They may be redundant, but it doesn't hurt anything. And there's finally the GTK 3.0. And let's see. These are Pulse. These are the Pulse audio libraries that you have to get into. Now you've got to have the development libraries installed. In many of these, you need the -dev, not just the plain old libs. And so you want to check that out because you are doing development here when you're actually encoding. And the export dynamic has to do with the dynamically linking callback routines, which, as it turns out, doesn't work. But anyway, the other stuff works in terms of setting up the size and setting up the widgets. But anyway, that's the compilation, and it does work, and that's the important thing. If it has redundancies in there, it doesn't matter, obviously. Okay, go back to, whoops, wrong one. Yeah, there it is. So anyway, the original code starts here. I'm not going to get into it. It's, there's where the Pulse, you can see there's some includes for Pulse interface and so forth. And then there's a bunch of windows. Many of these have been, a lot of material has been removed from them. The important thing here is, if I can find it, let's see, let's try R equals, yeah, there it is. It's in this routine right here. It's main window show levels. This is where it grabs the levels. Now this is set up for multiple channels. I'm assuming only 2 channels, left and right. I've never seen it work with more channels, but apparently it's set up to handle N channels. As you can see, the N's above there, especially N channels up here. I've not played with it, don't know. So I'm just assuming left and right. If N is 0, I'm assuming it's left. And if N is not 0, I'm assuming it's right. That may not be a correct assumption. If you've got, something else going on, you may need to change this. And not sure what that function does. I don't have any who knows? I think it's a Pulse function. But anyway, that's his or her original code. There's a logarithmic level here. I've fooled around with different numbers. This one seems to work. Many of the numbers I've used for multipliers and for parameters have been empirically determined. I just played with them until I got some numbers that looked good on the screen, looked good as a result. In any event, that's all I really care about that until I get down here to the main program. And the main program is, that's where the modified PavView meter ends, and this is where my stuff begins, which is also GPL'd. And I've got my own include files, which are largely the C include files as opposed to C++. There is my usual set of widgets up here, including the image and so forth. Some functions that are being declared, the timer handler, because this is based on a timer. It clicks every... it's got up to every 1/10 of a second to go up there and update the meters. You can speed that up or slow it down if you want to. How to destroy it. This is the callback for the draw routine because I had to do it manually, so it's declared at the front. There's a style which determines whether it's got needles or arcs. And there's image, whether or not the image is to be shown or not. There is my standard input first line. Don't know why that's in there. It was in the original code. I left it. This was not in the original code. It was probably brought in as a result of another library, but that's my insertion. So from here on, it's a mixture of mine and the original. It kind of varies. Here's where I'm going through the arguments that came in, and you see where they're all tested for, and they're setting up values into style and record. Record is by default false, which means it picks up the playback. If you want to go to the so-called record, the microphone input, you have to say go to record. That's the original names they used. He parsed them differently, so the original parsing is missing. There's where we go down into GTK to initialize it, which has been done before. This is where the modes are set up. That's a message that comes out telling you. It's a printout with some colors on it. It tells you what the which mode you're in and so forth. This was part of the original parsing scheme. I left it in here. It's not functional. I may go back and try to fix it up later. Instead, I've already taken care of it. And the remains of what was above there is here. We get the environment. If it's record, we're going to get pulse source, or we're going to get pulse sync. That's what we're looking for in the environment. and we get the device name out there, and this, and more messages and so forth. This sets up the connection with Pulse, and it sets it up whether you're going to be reading from the data that's in the playback side or in the record side. So that's what's going on there, and it's a bunch of his code. I'm not going to get into it because I don't understand the interface, and I don't care because it works. And as long as it works and doesn't bother me, I'm not going to bother it. Okay, there's the builder thing as before, and so forth and so on. And here's where we pull out the widgets and get them set up. They do set up, but this is someplace right about here is where you're going to get that warning when it sees draw 1, because for some reason it's not connecting. I don't know exactly why. You know how C++ has a curious way of binding to functions, and there may be some parameter I don't know about. But anyway, you get a warning saying it can't find the onDraw1 draw function, which is contacted. This is where its life comes from, this line here. And so what? There's the unref. Here's where I manually do the callback. And I G-signal connects to onDraw1 draw. So it's manually doing the callback, so everything's fine, works. I still have the keep above in here. You don't have to show the window. Add the timeout. It's 100 milliseconds, I guess it is. So a tenth of a second. You can change the amount of time. You can increase it, say, to 200 milliseconds. It should be 5 times a second. This is 10 times a second, optional. If the image is not true, if the image is false, then I hide the image 1, and that gives you a background of gray or some other color or something else if you want to. This is same as above. On exit, he had these things in here which detach stuff. I don't know if it makes any difference to have them or not, but I left them in. Now we're back into the code you've seen before from previous examples. There's the destruction. There's some defines. Okay, here's the timer. The timer is going to get hit 10 times a second. When I get numbers back and they're coming through L and R, that in order the needle's not going to jump too jumpy. I average or smooth it. The number of items to smooth it by is LAT, and I've got it set to 4. And it sets up 2 arrays of 4 elements. You could be more elements or fewer elements, all the way down to 1. And what it does is it puts into the next slot of those arrays R and L. If R exceeds LAT, then R is set to 0, so it's just a circular array, basically. I initialize accumulators to 0. I go through the array. I add them in. I divide by LAT. Now I'm getting an average. And that means as if the value coming back jumps a lot, it'll take a couple more cycles before the needle gets up there. The needle's going to move up more slowly. It won't. You're trying to imitate the ballistics of a physical meter, the real VU meters, which of course have a momentum to them. They don't move instantaneously. There's a ramp up speed and they slow down speed and so forth. They have a physical characteristic, and you want to make your desktop meters look something like that. There's lots of factors or multipliers going in here to get the numbers to values that are useful when I do the drawing. So the factor there is 36, and this is just determined by trial and error. You can try bigger numbers and lower numbers. They just enlarge the range of the arc, and the lower minimum there is added in. Could be done a little differently, I guess, if the factor, if Lx is below a certain value, to set it to lower and so forth, or Ry or Rx or Lx. But anyway, I did it this way. That keeps the meter from disappearing off the left side of the screen, from going down to 0. It's kind of in minimum position in the arc, and if it's too great, again you give an upper limit to it. Okay. And after you've done all that, after you've been through the timer, you queue up a draw episode. So what it's telling the GTK system is that, okay, we're ready to draw the window draw 1, and it will, since there's nothing else to do, that's what comes next. All right, here's the draw window, and we've got a bunch of variables up here, horizontal, vertical. T1 is going to be the actual amount that we're drawing by, the length of the needle, and I don't know if var 1 is actually in use. I think it's I think that's dead. Yeah, that's what I thought it was. It was from an earlier experiment. Okay, and X and Y are going to be used to locate points. And so I leave in this width sort of thing. It is possible to redo this so that if you resize the window, everything in it will resize, at least the needles and so forth. I don't do that, but if you're going to do that, you need to know what the current width of the window, width and height of the windows are. And so this would tell you it's not being used here. So it's there if you want to play with it and make the thing dynamically resizable. Of course, you've got a problem with the background image, but anyway, there's probably a way around that. You can be rescaled. Sets the width of the line, and 3 somethings, I don't know what the units really are, they don't seem to be pixels. It seems to look good. This is the width of the lines that are going to be drawn. All right, if it's needles, okay, this is the needles situation here. If it's not needles, it'll be an arc, and the arc is down here. You see the else at the bottom of the thing. So this is needles, and it's a little more detailed because it's the first one. The amount to draw. Now we're going to do the left channel first, then the right channel. Right channel comes second. The right channel will be written on the screen secondly, so the right channel will be on top of the left channel. So if the left and right are close to one another, the right will obliterate part of the left. If they're within a certain range of one another, they will be, the color will change to black, indicating they're coincident. Anyway, I divide LX by 100 and multiply it by 3.14 because everything's done the arcs are all done in radians, which is nightmarish. But nonetheless, that's the 3.14 is because of it's pi, obviously, or part of pi, small chunk of pi. Getting much more detail than that doesn't really show up on the screen. Okay, that's going to be the amount of deflection. Where is the bottom? Where is the point where the needles originate at? It's going to be at 144 horizontal and 220 vertical, going down from the top. That is off the screen. That is outside the window. That creates the impression that the origin of the needle is below the window. And the reason why I do that is with many of these background images, they're not they're an arc, but they're an arc which, if you found the center of the circle they describe, it's off the screen. So that's why these numbers are off the screen. And let me just bring it up here. See, what have I got here? Yeah, you can see that this thing isn't originating right here. It's originating someplace down around here, hypothetically. But because that's not a circle. I mean, it's part of a larger circle, but it's not completely contained on this screen. So I hypothetically, let me start the music again, and so the implied origin of these needles is far down here. If you made the origin of the needles here, it would just go in a little arc right like this, and it would look funny. Okay. You notice when they came together there at the beginning, they were black because they overlapped. Yeah, there it is. If they do overlap, it turns into black. So that tells you that you're running a monaural, or they happen to be coincident. All right, so that's the business of those. The length of the needle is by default 170. That's if you got an image. If you don't have an image, I change it to 220 because there's no metering numbers up there. Just make it bigger. You can change that, obviously. Okay, Cairo, create an arc. Create an arc with the origin of the arc, or the center of the circle at HOR and VER, hor and ver, okay? This is the center of the circle of the arc. This is the length of the This is the radius of the arc going out to the edge, and this is the left starting point. This is the right starting point. These are in radians. They're nightmarish to work with. You probably, if you fool with them, be sure you have something calming, because everything seems to work backwards. But that's what it's actually doing. It is all inverted because they start on the right side and they work to the left, and so I really want to start on the left and I want to work to the right. But anyway, that's the starting point. That creates the arc from the left-hand side to the right-hand side. The next thing, it doesn't draw the arc. It just mentally, or in code or in memory, it creates the arc. Nothing's been drawn yet. The Cairo get current point, this took a while to find, gets the point of where the arc is on the arc circle. Okay, HOR and VER, the center of the arc, and X and Y will come back. Notice their addresses are going to come back to be where the point on the arc is that we didn't draw it, but we're set up to draw it. Okay, I don't want to draw the arc, so I destroy the path. And I create a new path. That gets rid of the old path. So the old path being the old arc. So then I moved the imaginary cursor on the screen to X and Y, that point. And then I set the color, probably should have set the color above, but I set the color to green. It's red, green, blue. I think below I've been using lower numbers, zeros or something to get, you can play around with the colors, obviously, but red, green, blue, so obviously max is 1, so that's green. And then, so that's kind of an interlude. First of all, I moved my imaginary point will be drawn is moved to X and Y. Then I draw a line from that imaginary point to horizontal and vertical. So I draw a line from that point on the arc to it. So there's your needle. That's the needle right there. You don't see it until you do the stroke. Once you do the stroke, you will see it on the screen. And as a result, it gives you this. And again, if you see those are the needles. You can see the green one. It's I didn't recompile it, but it would be a little bit greener, I think, because I made. Let's see. It takes a long time to compile. I got so many libraries to go through, and I don't know if it's much greener. It's a little brighter, maybe, but anyway, so the point, and it draws to this imaginary center down here, and it works. Okay, the other side, the red channel, is the same. No comments here because it's pretty much the same until we get down here. I left out the comments. It's really only a few lines of code, but I didn't bother to reproduce the comments because it's the same thing. If the absolute value of the difference between the two of them is less than 0.1, then the color is set to black. Otherwise, it's set to red. And again, I'm using 4s here. I thought I'd changed all these to 0s, but it doesn't matter. You can fiddle with this if you want, and then it does the same as before, and it draws out the line. So there you are. Those are the needles. Okay. Alternatively, we've asked for an arc, and the arc is really only one set of code. It's just a question of you fill the arc in, and again to see what the arc looks like. It looks like that. Okay. Now, if you'd said no image, this would have been much bigger. But I said image. I didn't say no image. That's what it looks like. You see, you get two arcs and a line at the end of the arc, and that's the. They don't change color. They're not set up to change color. Easy enough to do, obviously. All right. Again, the stuff at the top here is the same. It's got the origin. If there's no image, you make it longer. We set the color to red. We create the arc. We put a line to the arc, and we stroke it. So it's actually faster to just do the arc. If you just want to do the needle and you want to eliminate the arc, you have to go through that business of finding the point, moving to the point, then drawing from that point back to the origin. So it's actually easier to just put the arc as it showed here. Now, if you want the arc filled in, here it is here. If the style says filled in arc, it's Cairo fill, and it will fill the arc in. So if I'd done that here, if I'd said filled arc, it looks like that. And the only difference is we have the Cairo fill in both of them. And there is this is the first one being the left channel, and the second one being the right channel. Again, it's the same code. It's just using could be made into a subroutine, made even shorter. There's just not a lot of lines of code here. The whole thing is 820 lines, and it could a lot of that's comments, and it could be, of course, compressed. So there you are. Whoops. Because I didn't write that stuff out. I'll recompile it just to make sure everything is kosher. And yeah, there it looks like. That's what it looks like. And which is a little bit different than the standard VU meter. And I think one of the things is that since it's been hacked, if you want to modify it, you now have the handles to go in there and make it do anything you want. It doesn't have to be arcs or anything like that. It could be a wavy line, a line trace, much like you see when you get when you do the system monitor here, where the lines will start coming up eventually. There they are, and you can see the trace. You could do quite easily that, because we did earlier how to make tracings, just line tracings, not a big deal. Yeah. You could modify it as you see fit. So anyway, that's a kind of a departure, but it's kind of interesting if you want to play with this. You could also, I did not do it, but incorporate the image into and the Glade file into as resources into the distributable file. And that was covered on a earlier video, how to create resources, how to incorporate this into the actual source file. So there's not multiple files. As it is right now, if you were to distribute it, you would have to have the executable, you'd have to have the Glade file, and you'd have to have the image. The compilation and the source code are not necessary, but in order for it to run, it requires all those. But if you incorporate the Glade file and the image as resources and insert them into the compilation process as we did before, then you will you only have one file to distribute. That would be the executable. Anyway, that's as much as this is going to do.